Hello, this lesson is for my pre-calculus students. Today I'm going to be doing lesson 48 on page 242, and it's called differentiation by U substitution. The very important concept here. It helps us take some pretty complex problems and make them manageable where we can go find the derivative or the differential of them. Before we get into the examples that they have there, I'm just going to look up here. Here's problem y equals e to the x. How would you find the derivative of that? Well, I know that the derivative, dy over dx, would just be e to the x. If they asked for the differential, just dy, that would be e to the x dx. We've multiplied both the left-hand side and the right-hand side of the problem by dx. No mystery there. What if it's e to the 5? The derivative, would it be 5e to the 5? No, it's just e to the 5. The derivative, there is no, that 5 does not jump to the front. What about the differential? Well, it would be dy equals e to the 5, and then not dx, but your dx would be the derivative of 5. Well, what's the derivative of 5? It's 0. What's going on here? Okay, a little bit of confusion. Not worry about this because they're never going to give you anything like that, but they are going to give you things like this. What if we have the derivative of that? Let's do the differential. Forget about the derivative. The differential is going to be e to the x dx, but dx. This has taken the place of the x like we had up here. We need to take the derivative of that. This is where this u substitution comes in handy. In u substitution, whenever they give you things like they do, that I just wrote there, and this is in your book also, we're going to change this expression here into the letter u. And we're going to say, we're going to work out the problem of e to the u. And then we're going to have some extra steps in there to find our answer. The book introduces you to this just by showing you this is how we're going to set it up. They show you that when they say it says it has the form of e to the u. I'm in the middle of page 242. The next one says y equals x cubed minus 2x squared plus 1 equals 100. Anything inside the parentheses, anything that has to deal with the x or like that quantity is going to become u. So we're going to be dealing with y equals u to the 100th power. Okay, and the next one, the natural logarithm of x squared plus 42. We're going to deal with the natural logarithm of u, where u is going to equal to x squared plus 42. In the next one, y equals the sine of x squared minus 15. X squared minus 15 is going to become u. U is going to take its place. The last one, y equals sine of x quantity cubed. In this one, and it's typically whatever is in parentheses, the u is going to take the place of the sine x, not the u takes place of this x. Now, if they had y equals the sine of x plus 4 and the whole thing was quantity cubed, we're going to have to deal with that at a later date. They won't give us anything that complicated yet. So let's look at these very first examples. I'm going to the top, or actually they do the y equals e to the x squared plus 2. E to the x squared plus 2, and they say, okay, u substitution. And they make a little box. They say, in this case, u equals x squared plus 2. Du equals the differential of this, 2x plus 0, because the derivative of 2 is 0. We won't need that. and then dx. The differential has that there. So they're going to change this y equals e to the x squared plus 2 into y equals e to the u. There's the information we need to solve this. dy will equal e to the u times du. Well, what is e to the u? E to the u is e to the x squared plus 2. What is du? Du is 2x dx. So my final answer becomes 2x e to the x squared plus 2 dx when they rearrange all these terms. It's a lot going on there, and in the final example, I guess they were looking for the derivative. They have dy, in the final answer, they have dy over dx. Okay, so they've got that in bold. Why they did that, I'm not exactly sure, but there it is. They didn't. If they had just asked for dy or the differential, we would have done it. I'm going to leave this up for a second. Let's go to the first example, 48.1. It says, do this, x squared plus 2x to the 10th power, and it says find f prime of x. That means find the derivative. They don't want the differential, they want the derivative. Y equals x squared plus 2x to the 10th power. Okay? And they want y prime. Before we do, we're going to say y equals u to the 10th power. And in this case, u equals x squared plus 2x. By the way, there's lots of examples, so this video may take a while. What is du? Du will be the derivative of x squared, which is x squared, will be the differential, x squared dx, plus the differential of 2x, which would just be 2 dx. They'll probably factor out the dx and just say x squared plus 2. And a lot of times they won't even put parentheses. They'll just put dx over there. I don't understand the inconsistency. All right, so let's find dy. Dy will be 10u to the 9 du. All right? We substitute 10, what is u? U is x squared plus 9x, all to the 9th power. What is du? It is x squared plus 2 dx. Because they asked for y prime, and y prime is dy over dx, they divide by dx, and there it is. 10 times the quantity x squared plus 9x plus 2x. I do see a copy error. 2x to the 9th power times x squared plus 2. And there we have it. Look at 48.2. (48.2) says the cube root of x squared plus 2x. Oops. Y equals. Well, what do they want? They say find h prime of x. Oh, okay, it was h to the x. Again, they want the derivative. So we need to say, okay, h of x equals x squared plus 2x all to the 1/3 power, right? So in this problem, I'm going to say h of x equals u to the 1/3 power. U is going to take the place of x squared plus 2x. Well, what is, we're going to do something different. Let's do this. H prime of x is going to be 1/3 u, what's 1/3 minus 1 to the negative 2/3 power du. That would actually be, I don't even know how you distinguish it over here. But there it is. We need to find this du. We've got the u. What is du? Du is the derivative of x squared 2. We already did this earlier, didn't we? Yeah. Plus 2, and then the dx. All right. So this final answer is going to be 1/3. Plug in u, x squared plus 2x to the negative 2/3 power. What is du? It is 2x plus 2. And then we'll take off that dx since they're looking for the derivative, not the differential. Forgive me, every time I do one of these, I just check the book, make sure I haven't done some really stupid error. 1/3 x squared plus 2x to the negative 2. Yep, hey, we're good. All right, moving on. I'll leave that one up. I don't know if we'll go through all of these, but we'll get through a bunch of them. Next one says natural logarithm of x squared minus 42. And that was g of x. They want g prime of x. They want the derivative, not the differential. So that means we're going to have to get rid of any dx's on the end. So this is the natural logarithm of u. What is the derivative of the natural logarithm of u? Well, it's just 1 over u. Okay. If we did the differential, let's think of that. That's going to be 1 over u du. We cannot forget that. Just at the very end, we'll get rid of the dx. So u in this case is x squared minus 42. Du is going to be 2x minus 0. I'm off camera, I see. So, and technically dx, but we're not going to have that in the end answer. So my answer is 1 over x squared minus 42 times 2x dx, which again, they'll get rid of the dx. So 2x over x squared minus 42 is going to be your g prime of x. Again, I'm checking, make sure I didn't get anything wrong. I didn't. Hey, other than writing down a copy error earlier, we're doing pretty good. You learning anything, Emma? My daughter Emma's sitting here playing a game on the phone. The next one says f of t equals sine of t cubed minus 15. We're going to change this into f of t equals the sine of u. In this case, u is t cubed minus 15. Are you getting the feel of this? Are you seeing the pattern? The du will be 3t squared dt. Oops, broke my chalk. All right. Well, derivative of this will be sine of u du. That's a u there. Okay. And that's a u there. So it'll be sine of still the t cubed minus 15. We haven't lost that. Oh, no. Oh, I made a mistake. What's the derivative? It's not sine of u. It's cosine of u. Derivative of sine is cosine. All right? And times, and that whole thing, and it's not times the t cubed minus 15. Then we have the 3t squared dt. So eventually we get 3t squared cosine of t cubed minus 15, and the dt goes away since they're looking for the derivative, not the differential. So, the next one where it says sine of cubed x, this was the sine of this. This is the sine of x quantity cubed. What do they say? Do they say y equals? Yes. And they want the derivative. Well, we're going to say y equals u cubed. Derivative That will be 3u squared du. In this case, u is the sine of x. What is du? It's cosine of x dx. Right there. So we substitute these in here. Y equals 3 sine squared x times the cosine x dx. They're looking for the derivative, not the differential. Hi, Jonathan. So that goes away. You have to save your question for a minute. I'm doing a lesson. Deep in. Stop. Stick around, learn something.
Hi, class.
Jonathan says hi, everybody. If you've got it, you can go ahead and turn off the video. I'm going to go to, we only got two more. 48.6 says y equals the cosine of e to the x. What are we going to make u there? Are we going to make it cosine or are we going to make it e to the x? U in this case is going to be e to the x. Let's see what the derivative is going to be. The derivative of cosine is negative sine e to the x. The differential is dx. Okay? Or in this case, we should have said, I should have said y equals cosine u, and the derivative is negative sine u du. That's what I should have said. All right, so if u is e to the x, du is e to the x dx again. Okay? So I'm just going to plug this in down here. Y prime negative sine of e to the x, and we multiply this by e to the x dx. I get negative e to the x sine x e to the x. Boy, I hope that's right. Yes, it is. All right. That one was a little goofy. Pretty discombobulated. We're at 17 minutes. Wow. One more. Last one. E to the x plus 1 to the 1/2 power. I'm going to say this equals y equals u to the 1/2 power. The derivative of that is going to be 1/2 u to the negative 1/2 du. So in this case, u equals e to the x plus 1. Du will be e to the x dx. There's no derivative of 1. So we have 1/2. What is u? E to the x plus 1, all to the negative 1/2 power, times e to the x dx. Dx goes away. So I have final answer, e to the x times e to the x plus 1 to the negative 1/2 power, all over 2. Am I right? No, I'm not. Oh, I see what they did. They put, because this is a negative power, they went ahead and put the e to the x plus 1 in the denominator with the 2. 6 of 1/2 dozen of the other. Okay, well, I hope that wasn't too confusing. Lots of examples. I was working pretty fast. Even made a little mistake here and there, but easily picked up. All right, use the book, follow the examples. Best of luck to you. See you guys later.